Hey guys, welcome to Pre-Calc Lesson 12.8 on continuity. All right, so what makes a function continuous? Well, I'm going to throw this math definition at you right now. The limit of f of x as x approaches c from the left equals the limit of f of x as x approaches c from the right equals f of c. So what are we saying here? We're saying the left-hand limit equals the right-hand limit equals the function evaluated at that x value. The left-hand limit equals the right-hand limit equals the function. So basically what this gives us is a single pencil stroke. Okay, so you can go from negative infinity to positive infinity without lifting your pencil off the paper. That's what makes a function continuous. Okay, so what we're going to do now is we're going to determine if the following functions are continuous. If not, we have to state the type of discontinuity. Okay, so what I notice here, first of all, I have a piecewise function. This piece of it, x cubed minus 4 cubic, is continuous. That piece of it, x plus 2, is linear. That's continuous. So both individual pieces are continuous. That means the only place this could possibly have discontinuity would be where they change. Okay, so that would be at 2, but I don't know that. So how do we determine it? Okay, well, what we are going to do is, if you think back to this definition here, I need to show that the left-hand limit equals the right-hand limit equals the function. So if all three of those are equal, then my function is continuous. So what I usually like to do here is I like to evaluate the function first, because that's usually the piece students forget. So it might have discontinuity at 2, so I'm going to evaluate f of 2. Well, here's where you have to pay attention to brackets and parentheses. There's my brackets. That means this is including 2. So I'm going to plug into that piece. X cubed minus 4. 2 cubed minus 4. 2 cubed is 8. 8 minus 4 is 4. So now what I need to do is I need to do the left-hand limit. Okay, well, how do we write that down? That's going to be the limit of f of x as x approaches 2 from the left. Well, 2 from the left means negative infinity to 2. It's this interval right here, which means, again, I'm going to be using that piece, the x cubed minus 4. So once again, it's going to be 2 cubed minus 4. We've already established that's equal to 4. So I've got 2 out of the 3. Remember, you need 3 out of 3 if it's to be continuous. So now what I'm going to do is I'm going to take the limit of f of x as x approaches 2 from the right. Well, approaching 2 from the right means you're going from positive infinity to 2. So I'm talking about this interval here, which is x plus 2. So x is 2, 2 plus 2, that's 4. So what do we notice here? I notice that all three of these are equal. Therefore, my function is continuous. In example 2, we see another piecewise function. And upon further examination, we notice that top piece, x squared plus 7, is continuous. 12 is continuous, that's a constant. So the only place we would have discontinuity could potentially be 5. And again, I don't know that. We're going to determine that right now. So let's evaluate the function at 5. So where do we do that? When x equals 5, the y is going to be 12, so that's simply going to be 12. Now the next two are a little bit different than what we've seen before. I want the limit of f of x as x approaches 5 from the left. And I want the limit of f of x as x approaches 5 from the right. Now, this piece here says x does not equal 5. It can be anything except 5. So another way we could have written that would be something that looks like this. Negative infinity to 5 with parentheses, or 5 to infinity. So if I want the left-hand limit, I'm going from negative infinity to 5. Well, it's part of this interval, so I'm going to plug into that, x squared plus 7. Okay, so 5 squared, oops, let me change that. 5 squared plus 7 equals 32. And that's going to also be the piece I use for the right-hand limit from infinity to 5. So again, it's going to be x squared plus 7. That's going to be 32. So what do we notice here? We notice that these are not all equal. Therefore, it's not continuous. Well, if it's not continuous, it has discontinuity. All right, so the second part of the question is, if it's not continuous, what type of discontinuity does it have? And this is where we have to take a look at the limit. So I have discontinuity at x equals 5. So this is true, yes. But what type is it? Well, the limit exists. So if your left-hand limit equals your right-hand limit, the limit exists. But the function is something else. So this coordinate right here would be 532. But when we evaluate the function, f of 5 equals 12. So that means somewhere else down here, we'd have this coordinate here, 512. So we have a hole in the function here. It doesn't matter if it's plugged or not elsewhere. This type of discontinuity is called point discontinuity at 532. The second part of today's lesson is making functions continuous. So in this example here, I want to make f of x continuous if f of x is x squared plus 13x minus 30 over x minus 2. Well, if I'm asking you to make something continuous, that means the original has discontinuity. Where does a function have discontinuity? Well, when I give you a rational expression, what we're going to do is we're going to set the denominator equal to 0 for discontinuity. Well, I think it's pretty obvious to see here that if I take that denominator and set it equal to 0, I'm going to have discontinuity when x equals 2. So now, what do? Well, next we're going to take the limit of f of x as x approaches 2, that place of discontinuity. And if we try to do direct substitution, we already established that's going to be a 0. So what I need to do now is I need to clean this up. So I need to factor and cancel. So hopefully that numerator factors. X and x, signs are different, and multiply to 30, combine to a 13. So positive 15, negative 2. Denominator is x minus 2. Perfect. All right, so when I take this limit, I'm actually taking the limit of x plus 15 now as x approaches 2. Plug in that 2, and you get 17. Okay, so here's what we have. The function has discontinuity when x equals 2. But the limit exists. So basically what that's telling me is I've got this situation here. I've got point discontinuity. Well, how do we make that continuous? Well, we make that continuous by creating a piecewise function. It's going to have two pieces to it. The first piece is going to be our original function, x squared plus 13x minus 30 over x minus 2. Now, where's that going to exist? That's going to exist everywhere except 2, because remember, that's where we had discontinuity. So basically, that's going to create this. Now what I have to do is I have to create a value that will plug or fill that hole, and that's going to be right here, 17. And that's going to be when x equals 2. This is a piecewise function that is now continuous. I've made the original function continuous because what's happening here is I had a function that had a hole in it, and then what this 17 does right here is it plugs that when x equals 2. Let's try one more. Make f of x continuous if f of x equals x squared plus 5x plus 4 over x plus 1. So again, what we have to do first is establish where it has discontinuity. That's denominator equal to 0. So it has discontinuity when x is negative 1. Now I'm going to take the limit of that function as x approaches negative 1. Well, again, direct substitution is not going to work, so let's factor that numerator, x plus 4, x plus 1 over x plus 1. So basically what I'm using is the x plus 4 now in the limit, plug in a -1, and I get 3. So again, what are we saying? I have discontinuity when x is -1, but the limit exists. So visually, I've got something that looks like this. And I know this coordinate is -1, 3. So what I need to do now is I need to create a piecewise function that includes this part, and it includes a piece that will plug that hole. All right, so let's create a piecewise function here. F of x equals the original function. So that's going to be x squared plus 5x plus 4 over x plus 1 everywhere except -1. All right, so that's going to give us this. And now I need to create something that's going to fill that hole. So the limit was 3, and that's going to exist when x equals -1. So here's the piecewise function that'll create a continuous function from our original. It takes this, that's the top piece, and then we just plug that. So now we have a continuous pencil stroke and a continuous function. The final part of today's lesson, finding values of a and b to make a function continuous. So you'll be given a piecewise function, and there'll be a variable in one of the pieces. In this case, it's going to be a, and you need to find the value of that would make this whole thing continuous. So if you notice this top piece here, it's quadratic, and this is linear. So we're going to have something that kind of looks like this. Quadratic, and then I've got another piece that kind of looks like that. And what I need to do is I need to find the value of a that's going to make these pieces line up like so. All right, so how do we do that? Well, what we need to do is we need to find the left-hand limit. We need to find the right-hand limit. We need to make sure that those two are equal. Now, notation is very important in pre-calc, calc, higher level mathematics. So I know some of you can just like plug in numbers and determine this, but we need you to show this work. What we're doing is we're taking the limit of f of x as x approaches 2 from the left. So we're doing this visually. Approaching 2 from the left is going from -infinity to 2. So I'm plugging into that top piece. Okay, x squared plus 2. X is 2. 2 squared plus 2, that's going to be 6. So now what I need to do is I need to take the right-hand limit. I need to take this limit. Well, the right-hand limit's coming from infinity to 2, so I need to plug in to that. Okay, so the limit of f of x as x approaches 2 from the right. Ax, x is 2. So it's going to be a times 2 plus 6. So now, in order for this to be continuous, which is what I want, this and that have to be equal. So I need to set those two equal. Okay, so I'm going to have 2a plus 6 equals 6. Subtract 6 from both sides. 2a equals 0. Divide by 2. A equals 0. So what happens here is when a is 0, this piece here, this piece here lines up like so. If a is any other value, we're going to have a different slope, and they won't line up. All right, last one. A little bit more challenging here is we've got 3 pieces, okay? So what we like to do is we like to start top down, because we're going to have to actually find a before we can find b. So again, what I have here is linear. That's also linear. So I need to make sure when x is -2 that the left-hand limit and the right-hand limit are going to be the same. So again, let's work on our notation. Limit of f of x as x approaches -2 from the left, and then I need to find the limit of f of x as x approaches -2 from the right. So from the left, -infinity to -2 is going to be x plus 8. Plug into there. Okay, x is -2 plus 8, that's going to be 6 again. Now for the next one, -2 from the right, I'm coming from the right to -2. So I'm going to be using this piece right here, ax. Okay, what x is negative 2, so that's just going to be negative 2a. Now what I need to do is I need to set these equal. So negative 2a equals 6, a equals negative 3. So what I know is that when a is negative 3, these two pieces right here will now be continuous. So I'm going to use this in here to make these two pieces continuous. So now I need to do my left-hand limit and my right-hand limit again, but this time I'm doing it at 1. All right, so limit of f of x as x approaches 1 from the left, and the limit of f of x as x approaches 1 from the right. So from the left, I'm going from negative 2 to 1. I'm plugging into this, but remember, a is negative 3. So it's going to be negative 3x. All right, so negative 3 times 1 is negative 3. And now I need to find the limit as x approaches 1 from the right. That's going to be this, x squared plus b. X is 1, so 1 squared plus b is 1 plus b. So now what I need to do is I need to set these two equal to find the value of b. So I've got 1 plus b equals negative 3. B obviously is going to be negative 4. So when b is negative 4, these two pieces right here will be continuous. Okay, so a is negative 3, b is negative 4. That concludes lesson 12.8. Please reach out as usual if you have any questions. And again, we just appreciate you guys following along and continuing to work hard during our shutdown.